Welcome to the first Astroholic blog. A few weeks ago, I was lucky enough to participate in the 72nd World Sci-Fi Convention here in London at LongCon 3. And I had the chance to give a soapbox talk about my research on emerging galaxies. And I thought, oh, that could be a nice, interesting thing to share on the blog. So the talk is Smashing Galaxies. What I did in my PhD is looking at galaxy mergers to try and understand how galaxies evolve, form, and what are the steps that galaxies take to change. Our galaxy, like a good fraction of the galaxy in the universe, is a spiral galaxy. Spiral galaxies are usually considered young, in the sense that the stars in the galaxy are young. For that reason, they're blue. They're still forming stars, so it means there's still plenty of gas, so they're considered gas-rich. The other main type of galaxy is elliptical galaxies, or early type galaxies. Early types have their stars distributed in elliptical orbits around the central core, but with no specific plane orbit, so they can orbit the core in whichever orientation they prefer. Galaxy evolution implies that spiral galaxies evolve into elliptical galaxies. This evolution is not only in morphology, is also in mass, which implies that old and big elliptical galaxies probably absorb several other galaxies during their lifetime. In my PhD, I looked for the missing links between spirals and ellipticals. We know that there are mergers, merging galaxies turn one into the other, but what are the properties of these steps? What we did was imagine that every merger that we could take a picture of was in the same merger timeline, and trying to understand what was going on. Obviously, is not exactly like that. A merger takes over 1 billion years to complete. So what we were doing is similar to trying to understand how a car crash happens by having picture of different car crashes. We learn a lot about the different stages, and this allows us to understand better how galaxies evolve. But why are we studying galaxy mergers? My project focused on the local universe, which is everything in 3 billion light years from the Milky Way. There are about 1 million galaxies in the local universe, and about 3,000, which is 3%, are mergers. Understanding how mergers behave here, where we can see them quite clearly, we can study them in depth, allow us to understand what was going on in the early universe. A good example is the Hubble ultraviolet field. The Hubble ultraviolet field is an area of the sky that, even to our more sensitive telescope, at first approach, it looked completely empty. Hubble scientists decided to point Hubble there for 10 hours, and what they saw was spectacular. We were able to see as far in the visible universe that we could with Hubble, and we saw that all those primordial galaxies so far away, so little time comparatively after the Big Bang are all merging, are all interactive. And if we can understand how galaxy evolution works here, we can most definitely shed some light on how galaxy form and evolve in the primordial universe.